All right, I think we're online. We're running a little late, so sorry about that. Good afternoon, everybody, and welcome to this session where we're going to have a whistle-stop tour through Azure Batch, and using Azure Batch for large-scale parallel compute and HPC solutions. So my name's Mark Scurrell. I'm a program manager in the Azure Compute group, where I spend probably about 95% of my time working on Azure Batch, working with the engineering team on new features, and working with customers that are using or started to use Azure Batch. So just before we start, let's see, are there any Azure Batch users in the audience, or is everyone just coming to find out more? That's great, OK. So we've got one over there, two. So that's great. So I assume everyone else is just coming to find out more. So first of all, let's start off with the goals of this service. And really, it is to really enable you to take, could be simulations, algorithms, applications, and allow you to run them at scale in Azure. Normally on, I mean, it could be on anything from a few VMs up to thousands of VMs, tens of thousands of cores. And these applications, they could be cloud-native applications. We work with customers that use these applications. Maybe they've integrated with Cosmos DB. Maybe they've integrated with specific Azure services. But I'd say more often than not, these are applications that work on the desktop. They'll work on workstations. They'll work on servers. But the idea is, the goal is to be able to use those in the cloud and utilize cloud scale, elasticity, and so on. So one of the fun things about this job is that this sort of capability to run applications at scale, it really applies to so many different scenarios. And the sort of fun thing is I get to work with customers that just use Azure Batch for any number of things. So one day I could be working with a customer who's using it to process MRI scans, looking for early signs of Alzheimer's. Another day, a motorsports team that's using it to simulate different setups of the race car around all the tracks in the season. And then another day, and we'll see this a little later on, I'm working with a VFX studio who's using Azure to render the latest Hollywood movie. But you can see there, all these are real-world use cases, the sort of the broad applicability of this sort of capability to run these applications at scale. So there's two main types of applications that we want to cater for. The first one is probably the most, actually is the most common, at least that I've seen so far. And these are sort of when you want to run the applications and they run completely independently of one another. So, great examples here, these Monte Carlo risk simulations, rendering the movie where you're going to render each frame, and each frame can be rendered independently. So let's just the more VMs you throw at the problem, the faster you can get the problem solved. So these tasks, these applications, they run independently, they don't talk to one another. The other type of application that we have to take into consideration is sort of more from the sort of HPC side, or traditionally we call HPC, scientific computing, engineering, and so on. And these are applications that tend to use the message passing interface, API. So you have a process, or actually a number of processes run on a number of nodes, say 4 here, but they talk to each other. While they're running, they're all running and talking to each other and communicating with each other. So we have to cater for this as well with Azure Batch. And these tend to make very good use of the RDMA networking capability that we have in Azure on some of our VM sizes, such as the H series and some of the GPU sizes. So actually, one of the examples here is scaling out some of the AI training frameworks. And then probably with Batch, what we see with these MPI workloads is the ability to run lots of them. So instead of just having 4 nodes and running a job, you might have 40 nodes, and you can run 10 jobs at once. And almost like run a parametric sweep or lots of them in parallel. So we need to cater for that as well. So we've got one example here. This is OpenFOAM. This is from a partner of ours, Uber Cloud. You check them out, and they sort of really make it nice and easy to run engineering applications, HPC applications, and it's based on top of Azure. And these are sort of 3 OpenFOAM simulations. And you could run these in parallel. Maybe each one of them was taking 4 nodes. And you're running all 3 in parallel on using Azure Batch. So in terms of the requirements, it really also starts off with this application. In this case, say, I've just used FFmpeg, very popular open source transcoding application, knows nothing about the cloud, works on all platforms, works on the desktop, and so on. You need to get a bunch of VMs, so we make it very easy to configure, to bring up, to monitor, to manage VMs, to scale them up and down according to the load. And that's called a pool of VMs. And then we provide several ways in which you can get those applications on the VMs. So you might, probably again, most commonly up until maybe recently, was upload the files up into blob storage and then effectively copy them onto each of the VMs. Might run an MSI, for example. Other ways would be we've got container support now, so you can have a container image. You can have an application package, upload a zip. And of course, you can create your own custom VM image, upload that as an image, and then use that with all the applications pre-installed, the OS configured, and so on. So the first part is this resource management, managing the VMs, getting the VMs. And then the second part of Azure Batch is the job scheduling capability. So basically, we provide a job scheduler out of the box and the ability to submit your work via jobs, which is really a container of tasks, and individual tasks into that pool or a set of pools. If all the VMs in that pool are busy, then we'll queue it until the VM becomes free. So just to really highlight, the unit of execution here in Batch is really just whatever you can run on the command line in the VM. So you don't need to repackage your application. As long as it'll run on the command line, like FFmpeg here, take an input file, produce an output file, and some other parameters on the resolution. In this particular example, you can use that and specify that in Azure Batch. But of course, there's always the data involved. So you're always going to work with some sort of storage. Again, probably more commonly, this has been blob storage with Azure Storage. Upload the files to blob storage, and then copy whatever file required down, in this case, the input file, onto the VM, run FFmpeg, produce the output, and then take that output file and write it back to Azure Storage. We've seen increasing amounts of, or increasing occurrence of actually using, say, a file server here, for example, as well, especially in the special effects rendering cases. So all of this, while we want to cater for a large scale, make sure your pool's elastic, and you can sort of be efficient, make the best use of the resources, scale down the VMs when there isn't the work, scale up the VMs when there is the work, and generally be cost effective. So there's no cost for running Azure Batch itself. You pay for the underlying compute infrastructure networking, and there's no head node or anything to pay for as well. So just pay for the infrastructure. So one use case, I actually just came across these guys a few weeks ago, but I think it sort of really is a really nice example of a development case building a SaaS application on top of Azure Batch and really sort of benefiting from the flexibility. So has anyone been into the Microsoft resale stores and seen the big banks of screens? So there's, it must be one in Seattle, there's definitely one in Bellevue. So there's about 80 of these stores worldwide, and every single one in each of those stores, that layout of screens is unique. They've all got a big banks of screens. Sometimes they're sort of not that high, but run around all the walls. In other cases, especially the flagship stores, I believe, they're really, really sort of super high. So they wanted to create a service that made it, first of all, easy to author and lay out the assets required. So you might have a campaign. I think on the example here is this, I think, Sea of Thieves, Xbox. Allow you to sort of take a common set of assets and lay them out for the different screen layouts. But then sort of the big thing where they need, while you're laying them out and you want to try stuff out, but also before pushing that final button, is you want to be able to, you need to be able to render all the individual frames and then push them into a movie file, a video file, on the, to be played on all the screens. So this group, they need, when they push that button, they need to create 1,400, render and create 1,400 videos. They use Adobe After Effects and FFmpeg to do that. They use auto-scale capabilities to scale up and down the number of VMs according to the load. And the outcome is they're saving a ton of money because they pay for use. They get resources when they need them, hand them back when they don't. But they can also leverage the scale. So what used to take 1 to 2 weeks now takes them 4 hours. So in terms of the platform, just a very brief overview, we sort of have our infrastructure, our hardware, and we have our VM offerings, cloud services, VMs, scale sets. And Azure Batch sits on top of that, providing that VM management and providing that job scheduling capability. As with all these sort of platform services in Azure, we have APIs, and all the APIs you can pretty much think of, command lines, and various user interfaces as well to access this. So the main use case is the developer, being able to use the APIs. So you're either creating a SaaS application like the retail store application, or maybe a client solution as well. So one example here might be with the render managers. I'm doing a bunch of work at the moment with the virtual special effects companies. They often use render managers, so we've worked with a couple of the vendors there, and they've integrated Azure Batch. So that provides the overall rendering management experience and then calls out to Batch for hybrid use cases. So we've also built higher level capabilities ourselves on top of Batch. The Batch AI service, I think, will be featured in the conference and sessions. And then we also have some what we call accelerators or specific examples of workloads where we want to make it easier to leverage Batch and cater for specific workloads. So running R at scale and, again, VFX and rendering as well. So we've got some plugins there. So just a quick example. This is a real-world example of someone really using the elasticity that's provided by the cloud and Batch and using the autoscale capability to scale up and down during the day according to that load, so really sort of pay for use. The two quiet times there are the weekend, and sort of the default policy is to scale down to 0 at the weekend while there's no one there. In terms of the scale, this is something we did probably about a year ago now with Milliman, a big insurance risk software company. And they wanted to run nested stochastic algorithms, which can really leverage a lot of scale. So in this case here, they leveraged 150,000 cores. They split it over 3 regions to run this calculation over, looks like about 3 hours or so. So I think the cool thing about this is, 150,000 cores is pretty much a small data center, but they were up and running with that 150,000 cores, running those tasks in 15 minutes. So from start to go, you can be leveraged. You've got that sort of power at your fingertips now. All right, so that's enough of the slides. Let's just take a look at Batch. All right. So what I'm actually going to do is do some rendering. So what we're going to try and do is render some frames from an animation, and I'll show you those being produced. So the first thing I'm going to do is create a pool. And I'm going to do this. We've got some plugins, and I could create it via a plugin, but I just wanted to show you a little more depth, a little more detail. So I'm going to use the command line, and then I'll show you the configuration that I'm using. So I'm first of all going to do AZ Batch pool. And what I'm going to leverage here is there's a free open source application called Blender. I'll show you in a second. And I've got a sample model. So the first thing when I'm creating a pool with this template is I can just have a pool ID. We'll just call it demo. I'm going to pick a VM size, and rendering tends to like lots and lots of cores. So I'm going to pick a D64S V3. And then I've got 2 parameters here, which I'm going to use to create the pool. So I'm going to create, let's say, 5 dedicated VMs and 15 low-priority VMs. And we'll cover this a little later towards the end of the session. So I've kicked that off. Let's have a look at the portal. So this is the Azure portal. You've seen this all throughout the morning. I've got my batch accounts on the left-hand side. And what I've done for this demo, I've pinned the batch account I'm going to use over here. Select that. This is in South Central US. It's just where I sort of happen to have some cores and happen to have the data. If we scroll through the main options here, some of the concepts I've talked about, pools and jobs, are listed here. And if I select pools, you can see I had an existing pool, Blender Windows, and I've got this demo pool, and it's creating. So if I select that, we can see sort of the two types of nodes that I've got. The dedicated nodes, which are going from 0 up until 5, and the low priority nodes going to 0 to 15. So we'll see where this gets to. All right, so that's that. Next thing is data. So I'm going to bring up Storage Explorer. I mentioned earlier on that in a lot of cases, data gets stored in blob storage. So in this case, I've got the data, the input data, and the model stored in a blob container, Blender Classroom. So this is the set. We've got assets, textures, and then the blend files. This is sort of the main 3D model. So for example, I can select textures and some cork here. I can pull that up so you can see sort of the cork texture. So that's the input. And the output's going to get written to rendering output. And I've got one that I did earlier, of course, just in case network problems and so on. So we should see some new output appear here. So that's the data. Let's have a look at the application itself, because I'm sure there aren't too many 3D and VFX people here. So this is the Blender application. It's a really very rich application, open source, runs on all the platforms, used to create 3D models, all the assets, textures, and so on, and also has a rendering engine built into it as well. So this is one of their sample models, and I've got a timeline here so we can see it's actually animated with a camera flying through the classroom. So we've got a classroom setting. We can fly through that classroom. So that's the what we're going to go and render. So if we've got that, let's go back to the command. Oh, actually, so I didn't show you. Let me go here to the template itself. How did I create that pool? So the pool configuration, at least in this case, super simple. So the main things that I got prompted for, some parameters. So I need to specify an ID for a pool. It's got an optional display name. I specified the VM size, which came from one of the parameters, and you pretty much got all the VM sizes available in Azure. The virtual machine configuration I specified here as being one that we've got in the marketplace. This is a Windows one. It has all this rendering software included on it. It has the free Blender, but it also has software from Autodesk, 3ds Max, Maya, Arnold, and also has fairly written last month or so, we added Chaos Group's V-Ray to this software as well. So that's but the image. I'm getting a Windows image from the marketplace, and then I set the number of nodes, and I'm not auto-scaling, and my max task is 1. So that sort of just gives you a flavor. I invoked that from the command line, but effectively these are the APIs. If you call the add pool API, these are the parameters you would pass to that. OK, let's create a job, and let's have a look at the template for that. So the main thing on a job, as I say, the main unit of execution is the command line. And so you can see the command line here. We've got an environment variable for where we put the exe on the image. -b says, hey, run Blender in the background. We're taking the blend file from a working directory, writing the output, and giving it a certain name. So one of the things to notice here is we've also got the built-in capability to work with Azure Storage. So we're writing this output, assuming the task is successful on the upload options. We're writing the output image automatically back to storage. And then actually, in terms of the input files, we've got resource files here. So what these do is it'll take the input files that are specified, all the assets, and copies them onto the VM for me as well. So you don't have to write any storage code getting files onto the VM or storage code to get the files off back to storage. So if we run this job now, job create, oops. OK. So we're going to do, let's do 30 frames, 1 to 30. I think the pool ID was demo. All right, so that should be submitting. That'll create a job. It'll create 30 tasks associated with that job. There we go. And so that's where we'll see where we got to. I might have got here a little early. So this is our pool. It's actually creating. I've got my 20 nodes, but they're starting. So just while that starts, let's have a look at the job. So if we come back here, so I've got the jobs node here. I've got my demo. This is my demo 1, and we've named it according to the frames that I've got. So actually, here we go. So we've actually got one of these tasks that started now. A VM must have become available, and we've got the rest queued. If I just refresh that, yeah, so that's what we've got so far. If I go back to the pool, we should see on the demo. So, and I'll leave that up for a few seconds. So this is one of the key values that we see people leveraging is if these VMs come up in phases, then the nice thing is you can submit the job, they hang out in the queue, the tasks are in the queue, and then literally the second that the VMs become available and ready to use, they start getting leveraged. So they're lit up in green here. So these take about a minute and a half to run. Let me just jump back. We can just see the more and more are becoming available. Just some of the things about the job that you can look at. If we just select 0 and pull up the properties. So what you can see for is the command line, and we're executing the particular frame. We've got the creation time. And then once this is finished, obviously we've got the start time, the end time, what node it ran on, and so on. The other thing that you can do is to have a look at the files on the node. So for example, very common in sort of the rendering case is to actually have a look at the output. So we can see the output for Blender here and how it's sort of progressing through. So I imagine if I refresh this now, we should have completed. So that actually has completed. I should have an output. And if we go to my Storage Explorer, let's refresh that. So we've got demo 1 created for this job, outputs. I've got a few frames now created. And there's a single frame that we've just rendered. So just to give you the flavor for what this looks at, well, cooking shows, this one I developed earlier, so you can see how we took that model. And this is sort of the output with all these frames getting rendered. So here in probably under 10 minutes, we've created a big pool of probably about 1,500 cores and rendered probably about 40 frames or so, I think it was there, using Batch. All right, let's go back to finish off with our all right, so just to quickly point out what we did with showed rendering there. So rendering is some specific workload we cater for on top of sort of the core Azure Batch. And we've added, we create these marketplace images with the software, the free Blender, and the premium software from Chaos Group and Autodesk. And then we also have pay-per-use licensing for that software. So you pay for the VM by the minute, the nearest minute rounded down to a minute. And if you choose the premium software, we have a price for that as well. So that way you don't have to pay or worry about licensing servers and buying full-time licensing if you're just maybe using this rendering sporadically. You can access all this, as we've seen, through the CLI, but obviously APIs and our client tools. And then we also have some plugins. I didn't show you, but we had a plugin there in Arnold. We have a plugin for Maya and so on, and we're developing more plugins. So you can use this direct Azure rendering directly from the applications. So one use case is Jellyfish Pictures. Worked on some really cool movies, Hollywood movies, TV, and so on. They use a hybrid scenario. So they have an on-premises cluster, and then when they haven't got enough licenses or they haven't got enough capacity, they burst out to the cloud using Azure Batch. And Batch is integrated into the render manager they use, which is Royal Render. They can leverage CPU VMs. They can leverage GPU VMs. And then finally, the thing you noticed there was I specified dedicated and low-priority VMs. So one of the things to highlight is our low-priority VM offering. We've had it about a year now. But the key thing here is the 80% discount. I just pulled this yesterday. So just think price always, it always takes a look at the pricing page. So for example, for our 2-core VM, instead of 9.6 cents an hour, it's 2 cents an hour. So those VMs I got, instead of $3 an hour, were 64 cents per hour. So huge saving. It's available in batch. It's also available now via VMSS if you don't need the batch capabilities. And then one of the cool things about batch, though, is in the pool, as you saw, we allowed that mixture of the dedicated and low priority. So you've really got the flexibility. You can either go lowest cost, always use low priority, cater for the fact that some of those VMs, they may get preempted from you. There is an 80% discount. But you can also mix it so that you can have a fixed baseline for the VMs and mix it in with low priority. But the nice thing about that is the job that's using batch, it doesn't need to care. You can auto-scale the pool, you can auto-scale the mix of these VMs. The job and whoever's submitting the work doesn't care about that. So that's about it. So whistle-stop tour of Azure Batch. Thanks so much.